Well, I've actually realized that people in their CVs, they like to say they have good analytical skills, good problem solving, and critical thinking skills. So if you want to have exceptional analytical skills, then it makes sense for you to destroy analytical geometry, right? So let's give this question a good look. Well, here they say to us in the diagram, the circle centered at a point N passes through the points A and C. Now the points B, C, D, and E are joined to form a parallelogram such that BE is parallel to the x-axis. Now, what is the meaning of BE is parallel to the x-axis? Well, it means quite simply that BE is a horizontal line. And what do we know about a horizontal line? Well, is that the y values are the same at any point, or rather, for any value of x. In other words, the y coordinate of the point E, it's just going to be 2. Get it? Of course you do. So, yeah. And moving along, they say to us, CD is a tangent to the circle at a point C, such that the length of CD is 6 units. And they gave us a very nice and beautiful sketch, which is awesome. So let's go ahead and see what the first question is saying. Well, here they say to us, please write down the length of the radius of this circle, okay? And of course, we understand that the radius is the distance from the center to any point on the circumference. So meaning in this case, we can simply use the line AN in order to find the length of the radius. But now one thing we observe is that the line AN is a vertical line. Now the question is, how do we see that? Well, it's easy. It's because the x value at a point A is exactly the same as the x value at point N. So it's a vertical line. So every time we want to find the length of a vertical line, we only focus on the y values. So we say the bigger y value, which is 3, minus the smaller y value, which is -1. And we find that the length of AN is 4 units. So it means the radius is just going to be 4 units. And then we are fine. So now we move along to the next one. So here they say to us, please calculate the coordinates of the point C. And this is for 2 marks. And of course, we understand that point C is just the point of tangent C. Well, this one, you can actually do it in one of 2 ways. Now, the first way is by using inspection, and the second way is by actually calculating it. So what do I mean by inspection? Well, if AN is a vertical line, then it stands to reason that ANC, or simply AC if you like, it is also a vertical line. Why? Because it's just the diameter of the circle. Hold on. Did you hear what I just said? I said AC is the diameter of the circle, right? So which means the center is actually the midpoint of this diameter. So it means we can just use, oh wait, now I'm talking about calculation, no longer inspection. But nevertheless, sorry for messing up the order, guys. But yeah, we can just find the midpoint of, in fact, we are given the midpoint, which is -1 and 3. So we can just use the midpoint formula in order to find the coordinates of the point C. That is by calculation. But if we talk about inspection, we still understand that AC is a vertical line, which means the x value at the point C is -1. So now we just need to find the y value, right? And here we remember the most important thing we said, The distance from A to N is 3 units. In fact, it's 4 units, sorry. So what we are simply going to do here is to take our 3, which is the y coordinate, and we add it to 4 in order to get the y coordinate at a point C. So 3 plus 4 is 7. And there you have the coordinates of the point C. So let's just write them so that they can see. We actually wrote them. Yeah, so from inspection, we can simply say, well, we have -1 and 7. But if we actually need to calculate them, then we understand that, yeah, this is where the point A is. I forgot to mark it on the sketch. Well, I'm marking it now. Right. So we understand that N is the midpoint. And if we know the coordinates of the midpoint already, then we can simply separate the equation, right? So let's say the coordinates there are X and Y, but it doesn't really matter. So this is what we will say. In terms of the X coordinates, we have -1, and this is equal to the X value at C plus the X value at A, right? Well, of course, saying plus -1 is the same as this thing minus 1. So, yeah. And then we divide this by 2. And then we say, well, in order to solve for x, we are simply going to cross multiply. So we get x value at C minus 1, which is equal to -2. And we take this one to the right-hand side. So it becomes positive. And -2 plus 1, it's -1. Do you see that? Then we come for y values. We say the y coordinate of the midpoint is 3. And this is equal to the y value at C plus the y value at A. And of course, saying plus -1, it's exactly the same as saying -1. So that's what we'll just say. And this is what we have. And then we simply cross multiply once again. And we find that the y value at C minus 1 equals 6. And taking this one to the other side, well, you're simply going to get 7. So these are the coordinates of the point C. So now you know 2 ways of finding these coordinates. Of course, it's always nice to use inspection if it is possible. Right. So now you have your 2 marks, which is fine. Now, what does the next question say? Well, this one says, please calculate the coordinates of the point D. So where is the point D? This is the point D there. And remember that CD is also a what? Well, CD is also a horizontal line. Why? Because it's parallel to BE, right? Both of them are just horizontal lines. So let's go to the whiteboard and show no signs of messy. We don't become merciful when it comes to numbers. We need to destroy them. Right. So if we understand that CD is a horizontal line, what does it mean? It means the y value is the same at any point, right? So it means the y value of the point D, it's just going to be 7. All right? Of course it is. Now, what about the x value? Well, it's very easy. Here we are given the length of CD. And if we had to calculate the length of CD manually, we'd simply take the bigger x value minus the smaller x value. Remember that when finding a vertical length, we focus on y values, right? Similarly, when finding a horizontal length, we only focus on x values, right? But we know that the length of CD is 6. We are looking for the x value at D, but the x value at what? At C is -1. So this is going to give us a +1. And if you take it to the other side, it becomes negative. So it means the x value at C, in fact, at D, sorry, it's just going to be a 5 there. Yeah, so -1 plus 6, it's going to give you a 5. And you should be happy. Now you are analyzing. You can become an actuary by now. I trust you. So now moving on, they say to us, please find the area of the triangle BCD. And if you give triangle BCD a good look, you can see that it's not really a right-angled triangle. So the question then is, how would you find the area of this triangle? Well, I'm just going to underline it for you. So this is B, and that is C, and this is D, and this is what we have. So this is the area of the triangle, which we must determine, all right? And once again, we can also do it in one of two ways. So the first way is to remember what they taught us in Euclidean geometry. Remember that if you have a triangle, which is actually like this, how do you find the perpendicular height of this triangle? Well, it's rather ugly, so let's say this, so that it becomes good looking, right? Yes, how do we find the height of this, the perpendicular height? Well, this is how we find the perpendicular height, right? So the base is still this, and the perpendicular height is going to be that. Are you fine with me? No, man, you can't be fine with me. I wanted to say, are you there with me? Eish. So similarly, that's what we are going to say, right? So we just come and say, well, this is going to be our perpendicular height. So it's going to stretch from here all the way to there. So it means we just need to know what is the length of BC, because our BC is the perpendicular height, right? And since it's just the vertical line, then once again, we focus on the y values. So we say the y value at C, which is 7, minus the y value at B, which is 2. So we get a 5. So yeah, that is the height of our triangle. So we can now come and say, well, the area of triangle BCD, it's just going to be half base. Well, our base is 6 and the height is 5. So half multiplied by 6 is 3. And of course, 3 by 5 is 15. So our area is just going to be 15 square units, over and out. So that's the simplest way in which you can find the area. But then what is another way? Well, alternatively, you could have said, since it's not what? Well, since this is not a right-angled triangle, I can try to use the area rule, right? But in order for you to use the area rule, that's if you know this side as well as that side. Well, CD, we know it already, so we don't need to find it. But you see, it's going to take us a lot of time. So let's just forget about it, guys. We found the easiest way. What more are we asking for? Yeah, so since you're not asking for more, then it stands to reason that we should move along to the next question. Well, this is where it gets interesting. So here I need you to pay special attention, even if you don't have any money in your bank account. Right. So here they say to us the circle centered at a point N is reflected about the line y equals x. M is the center of the new circle, which is now formed, right? And the two circles, they intersect at points A as well as F. And then firstly, they say to you, please find the length of NM. Well, this one is straightforward. But the most interesting one is this one. So here they say to us, please find the midpoint of the line AF. But this is what we need to remember. What is the meaning of you are reflecting a line, in fact, a function or a circle about the line y equals x? Well, it's easy. It means very simply that you are finding the inverse of this circle. Even though it's not a function, but we are finding the inverse of the circle. So let's try to make a sketch and see how both of these are now going to look like. And most importantly, we need to decide, because the first question is asking for the length of NM. So it means we need to know what are the coordinates of the point M, the center of the new circle. All right. Okay, fine. So what are we going to say here? Well, we can just get rid of this. I don't think, no, it's not necessary for us to have it. So it might as well go away. Yeah, anyway, these points are not lying on the circle, so they're not so useful after all. They have served their purpose. Right. So this is the line y equals x. Of course, you're going to do it as a dotted line, but seeing how I'm a tutor, it means I can just use a solid line, right? Yeah, but you'll do it as a dotted line. And of course, you label it and say, it's the line y equals x. Now, how will this situation, or rather this circle, look like after we reflected about this line? Well, the easiest way to understand that is to first find what? Yeah, that's a very good question. It's to first find what? And by the way, we need to be very, very careful, because the line y equals x is going to pass through the point A. Because think of it, y equals x. It means when x is -1, y is also going to be -1. So it has to pass through this point. We don't just draw it. We must be extremely careful. So yeah, more or less, this is how y equals x is supposed to look like. Okay, fine. Let's talk about the centers first. And this is literal. You had the point N, which is -1 and 3. So now we want to find what? Well, we want to find what? The coordinates of the point M, okay? And we reflect this point about the line y equals x. This means what as y becomes x, and what as x becomes y. It's literal. So in other words, when x is 3, which may be somewhere there, then y is going to be -1, which can be somewhere there, okay? Okay, fine. Of course, they didn't ask you to make a sketch, but it's really helpful for you to visualize your situation. So it's highly recommended you make your own sketch aside. But you need to remember that, yeah, they need to intersect like that. And this thing is supposed to pass exactly there. So I'll just have to redefine my point, or rather reposition it. Yeah, let's say it's going to be somewhere there. Remember, guys, it's not drawn according to scale, right? Yeah, the accuracy is not the whole point. The whole point is for us to visualize the situation. So this is the point A, and this one is the point F. So this is what we have. And remember, the point F was not there originally. It's just the point they had to name now that they say it's another point of intersection. Okay, fine. So what is the question looking for? Oh, firstly, they said find the length of NM. Now you know how to find the length of NM, right? Because you'll just say NM is the square root of the x value at M minus x value at N, y value at M minus y value at that. And of course, you know how to proceed from here. So I don't need to bore you with finding that length. So let's get to the juicy one right away. How to find the midpoint of the line AF, okay? Okay, fine. So somewhere along here, we are going to have a midpoint. I'm not saying the midpoint is going to be at the origin. Remember, this is not drawn according to scale. It may be here, it may be there. We don't know, but it's going to be somewhere there. So the question then is, how can we find the coordinates of the midpoint? That's a very good question. Well, this is what I want you to realize. What is it you realize? Guys, you need to analyze, ne? And you need to remember that mathematics is mathematics. There is no paper one, there is no paper two. Maths is maths. And it doesn't mean just because you're doing analytical geometry, you can't borrow a principle from trigonometry or a principle from Euclidean geometry. Now, this is what I want you to realize. If you look at AF, what do we call it in Euclidean geometry? Well, it's a chord. Okay. And what do we call a line from the center to any point on the circumference? It's the radius, right? But then what if this line was to end somewhere there on the chord? What did we say about this line? Well, we simply said the line from the center. In fact, what did we say, Gunjan? We said the perpendicular drawn from the center of a circle to a chord bisects the chord. Do you remember that theorem? Okay, but then it seems like I'm making up my own theorem because who said they're going to be perpendicular to each other? Who said that? Yeah, that's a very good question. Who said they're going to be perpendicular to each other? Yeah, I'm still looking for that person. Who said that? Well, I'm not really making my own theorem, but it's actually true. So every time you draw the radius, or rather a line from the center to a chord, it's going to be perpendicular to the chord, right? So if it's perpendicular to the chord, it means it bisects the chord, right? But even though that is true, it's not really the principle that we are going to use in order to find the coordinates of the point that is in the center there or in the midpoint of AF, right? But it's the principle that we are going to use. Okay, so how do we use this principle? Well, it's very easy. If we can find the equation of the line NM. And here we already know the equation of the line AF. It's y equals x. So if we can find the coordinates of the point of intersection of these two straight lines, then that, or rather those coordinates will actually be at the midpoint of AF. Do you get it? That's Euclidean geometry assisting us, because we are using the fact that every time you draw a line from the center of the circle to a chord, that line is always going to bisect the chord. Yeah, if it is perpendicular to the chord, of course, it's going to bisect the chord. So remember, this is just a single straight line, right? Of course it is. So this is what we will say then. We need to find the gradient of the line NM. So it's going to be the y value at M minus the y value at N. And we divide this by the x value at M minus the x value at N. So in the numerator, we have -4. Denominator, we have +4. So it means the value of the gradient will just be -1. Okay, fine, so what? So we know the value of the gradient, so we can just go to our slope point form, or you call it a point slope form. I'm not sure, but that's the name of this equation. So we can substitute either point N or point M. It's up to you. So let's use point M. So the y value is going to be -1. And this is what you have. So here you have y plus 1. And here you have -x plus 3. And taking this one to the other side, you find that the equation is just going to be -x. And then you say +2. So this is the equation of the line NM. So now that we know the equation of NM, we also know the equation of the line of symmetry. Then we are just going to equate those two, because where they intersect, it's at the midpoint of the chord AF. So we say y equals y, of course. So meaning -x plus 2 equals x, which implies that 2x equals 2, which later implies that x equals 1. So now you know the meaning of this sign, but of course you're not allowed to use it because you're still young. So it's an implication. You still stick to your equal signs and the normal steps, right? So now that we know the value of x is going to be 1, then it stands to reason that the value of y is also going to be 1. So now you can conclude and say, therefore, the coordinates of the midpoint, or maybe you can just write it nicely and say, it's the midpoint of AF. It's just going to be 1 and 1. And then you get your very nice and beautiful marks. So I really think this is the easiest way I could have done it. But of course, it's not the only way. So if you have another way of doing it, please feel free to share it with us, either in the comment section or I don't know where else. But I think the comment section is the best way out. But this is the easiest I can think, guys.